So hello everyone, this is lecture 17 for the electricity and magnetism. The last lecture we have completed the electrostatics, and today we will start the motion of charged particle inside the electric field and the magnetic field. So this is our topic, motion of charged particle in the electric and magnetic fields. So first we will study the motion of charged particles in the uniform electric field. So first in the electric field we will see in the direction of electric field, means charge is moving in the direction of electric field. So that will be a straight line motion because of plus q charge that will feel force in the same direction. For the minus q it will feel in the negative direction. So this kind of force it will be there, and motion will be straight line. And now we can just deduce some formulas that force will be q multiply electric field, and we know force is equal to ma, means mass and acceleration, that equal to qe. From here you can find the acceleration, that is qe by m. This all we discussing in the straight line motion. Now d square r by dt square, this is your acceleration, that is equal to qe by m. From here you can just integrate this with respect to time. You will get dr by dt equal to qe by mt plus some constant. Now see, this is some kind of equation you will get in the equations of motion. So that is the same thing, means now at t equal to 0 you will get initial velocity, because this is representing velocity. So at t equal to 0 c1 will be u naught. So now this equation will become v equal to u plus at, same just like we have in the equation of motion. So where the c1 is nothing but initial velocity at t equal to 0, and this equation you must remember, this is like a first equation. Now dr by dt equal to qe by t plus c1. Now we can again integrate this equation, so you get this thing. In place of c1 we have u naught, so dr by dt is equal to this. So dr will be, integrate this complete equation, it will be r t square by 2, and it will be u naught t plus some constant. Now see, this is some second equation, so that you can find a c2. How? Initial position takes 0, so at t equal to 0 r equal to r naught, that will represent the displacement actually. So at t equal to 0 r equal to r naught, so c2 will be r naught. So this will be your second equation. Now r minus r naught will represent the displacement in the equation of motion. Here it will represent the displacement vector. So this you can remember this like ut plus half at square, where acceleration is qe by m. So you can remember these results. Also you must remember, if initial velocity is 0 and initial position vector is 0, then v will be qe by mt. From here u naught is 0, so this v will be qe by mt, and r will be qe by 2m t square, because this will be 0, this will be 0. So must remember these results. So you can just find the analogy, that's how you can remember. Now see, if the electric field is in this direction, and there are 2 points 1 and 2, velocity at first point is v1 and second point is v2, and potential difference between these 2 points is v. So the work done required to move particle from here to here will be v multiply q. So that will be your total work done. Now that must be equal to the change in kinetic energy that you remember from the work energy theorem. So it will be equal to delta kinetic energy. Now kinetic energy change will be half v2 square minus half m v1 square. So this will be your work done. Must remember this result. Now the second is, this time the charge is moving perpendicular to the electric field, means we have electric field which is perpendicular and charge is moving perpendicular to it. So this is your electric field and charge is coming from here, so it will be perpendicular to this. So what kind of motion it will have? So let's see. And this is representing x, this is representing y, and also we will deal some question that if this is your field in the field region, in the charged particle, and after it will be in the non-field region, field free region, and this is your screen and this is your origin, that at what length this particle will strike. Okay, so we need to find this d length also. So in this we will understand all the concepts. So first, this particle is coming, so it will have the perpendicular vy velocity as 0, but vx velocity is same as v, and we will see that acceleration in the x direction will be 0, because force is, electric field is in the perpendicular direction only. So we'll have the acceleration in the y direction. So in the x direction, initial velocity will be equal to v, whatever the velocity we have, and acceleration in the x direction will be 0 because there is no force. But in the y direction, initial velocity is 0 in the y direction, but there will be acceleration due to this electric field, that will be qe by m. Now see, you can just tell the position by this velocity, means distance equal to speed multiplied time. So it will be ux t, and ux is v, so this will be your x component. With of time, means this will x will change like this. Now how y will change? So we'll use the second equation, y equal to ut plus half at square, u is 0, and it will be half a by t, half at square. Now ay is nothing but qe by m t square. Now we have y changing with respect to time, and we have x changing with time. So what we need to plot this, we need how y is changing with respect to x. So in place of t we will write x upon v. So it will give you x square over v square. So that will be this, y equal to qe by 2m x square by v square. Now see, the relation between y and x is parabolic. So y is changing as x square. So the trajectory will be parabolic. Now we know how the trajectory will be. Now how to find that at what point will strike. So see, first we need to find this length y1, at what point it will going out of this field region. So for that we know this length is L, capital L. So if x is L, then we need to find the y. So we can use this equation simply. X equal to capital L, then y will be QE L square by 2m v square. So that will be your y1. Now you have y1, but to find this complete d length you need to find this y2 also. And see, after the coming out of this region it will go into the straight line. So to find this y2 you need to find this angle first, and this length is already known, that is L. So tan phi will be equal to y2 over L, and y2 will be nothing but L tan phi. So y2 is L tan phi, but we need to find this phi to find this y2. So how can we find phi? See, the deflection of the particle is changing with respect to x, means with x changing, this phi is changing or theta is changing, means phi is at particular this angle, but this theta is changing. So at any point this theta can be given by dy by dx, tan theta equal to dy by dx. So we just find the dy by dx from here. Dy by dx will be equal to this. This will be your dy by dx, qe x by m v square. Now see, this will be theta at any point x. Okay, because this theta is changing with respect to x. So at any point x, this will be given by this. Now we need to find the theta at this point, because at this point theta will be equal to phi. So at x equal to L, so it will be QE L by mv square equal to tan phi. Now from here you can find the tan phi is this. So y2 will be L tan phi. So now you have y2, you have y1, just add them, you will get the distance at which this particle will strike. Now I hope it is clear to you how the particle moving the perpendicular to E. So let's see now the motion of charged particle in the magnetic field. So I am first time introducing this magnetic field. So if in the steady wire, means the current is flowing in this way, then use the right hand screw rule, and this will give you a direction of magnetic field, means thumb in the direction of the current, then curling of your fingers will give you your magnetic field. This represents the field coming out of the paper, and this represents the field going inside the paper. And same is, if current is going in negative direction this way, means then the magnetic field will be in this way. So that's the how you can find using the right hand screw rule. Same, if the current is in the circular loop, then the curl your finger in with the current, then the thumb will give you the magnetic field. So I hope this is clear to you. This is the basics. Now let's understand what will be the force in the magnetic field on a charge. If charge q is moving with respect to with velocity v in the magnetic field b, then F magnetic force will be equal to q v cross b. This is also called the Lorentz force, and this will give you the direction of the Lorentz force v cross b. Now we will study two cases. First, it is entering direction perpendicular to b. Now the v in perpendicular to b, then what kind of motion it will have. So whenever v is perpendicular to this b, then using the screw rule, v cross b, so v and b is going downward, so it will give you force in perpendicular direction to this b. And similarly, if we draw a circular loop, then it will see that at any point it is going giving the force in the center direction, means this force is acting as a centripetal force, and charge will move as in a circular motion. So if it is moving in circular motion, let's find the radius, velocity, and time period and frequency, all of them. So let's see how can you find. So F magnetic is q vb sin theta. Theta is 90 between v and b in the circular motion. This must be equal to the centripetal force, that is mv square by r. Now from here r will be equal to mv by qb. See, you can find this from here. Now sin 90 will be 1, and we will cancel out. So r will be mv by qb. Now what is the time period? Time period is total distance divided by the velocity, 2 pi r divided by v. And you can write this in terms of qb also, because you know r, so just substitute r here, you will get t. Now f will be 1 upon t. So this is frequency, so it is 1 upon this, it will give you qb by 2 pi m. Similarly, angular frequency is 2 pi, this frequency, it will give you qb by m. You must remember all these results. Now momentum also can be found, that is mv, and just substitute the value of v from here, that is qbr by m, you will get qbr. Now kinetic energy is nothing but half mv square, substitute value of v, that will give you m square v square by 2m, q square b square r square by 2m. So this is your kinetic energy for this circular motion. Let's take an example based on this. We have neutron, proton, electron and deuteron, and we need to tell the trajectory of these particles in this magnetic field, and they are all moving perpendicular to this. So what kind of motion will have? See, neutron have no charge, so that's why it will move forward. It won't feel any force due to magnetic field, so it will go straight forward. Now what is the for electron, proton and deuteron? And what is deuteron? Deuteron is nothing but nucleus of deuterium. Hydrogen have three isotopes, that is protium, deuterium and tritium. So deuterium is the second isotope, which have two, means one proton, one neutron. So let's see, we need to deal with the nucleus. That nucleus is called a deuteron. So for the neutron, charge is 0, magnetic force will be 0, so it will go straight. Now radius of electron is nothing but v over ev. So radius will give you the motion, means what radius will have. So this will be for electron. Now for the proton, it is mp v over ev. So mass of proton is nothing but 1836 times mass of electron. You must remember this number. So this radius also will be itne times, means this time larger than electron. Now for the proton, means this result you must remember, we used it here. Means now if mass is this time larger, now this is the radius of electron, so radius of proton will be 1836 larger or radius of electron. So radius of electron, if this is your radius of electron, then proton will be very large radius. So this will be your trajectory. Let's find for the deuteron. Deuteron is 1s2, so 1 proton 1 neutron. So mass of neutron is approximately equal to proton, so we will get 2 mp. Now just in place of md we will write 2 mp, and this mp, now this is nothing but radius of proton. So deuteron radius will be twice than proton. So if this is your proton's circular motion, this is your very large radius, then for deuteron it will be larger than proton also, so it will go something like this. So that's how you can draw the trajectory, by just checking the radius. Now let's see in the direction making an angle theta with b. Now this time the particle or the charge is not moving perpendicular to b, it is making some theta angle with the magnetic field. Then what kind of motion we will have? Now see, when it is making some angle, then there will be a resolving vector in the perpendicular direction and in the parallel direction of the magnetic field. So the perpendicular vector or the resolved vector component will give you motion in the circular motion, and the parallel vector to the b will give you your forward motion, straight line motion. So the resulting structure is nothing but a helical structure you will get. Means the perpendicular component is giving you circular motion, and this parallel component to the b will giving you the forward motion. So that's why you will get this kind of a structure. So the circular motion is due to the perpendicular component, so we'll get the radius helping this with the help of this. So radius is nothing but mv perpendicular divided by qb, and time period will be 2 pi r by v perpendicular. So one circular motion will take this time. In this time, what distance is traveled by the particle in the forward direction is called the pitch. So time will remain same. So v parallel multiplied by time will give you your pitch. Pitch is this distance. Pitch of the helix d, distance traveled in field direction 1 revolution, that is this, and this will remain constant. And this is called the helical motion, and this is helix. Let's see some example based on this. A beam of proton with velocity is given, enters a uniform magnetic field 0.3 Tesla, and angle is given between the magnetic field and the particle 60 degree. So the magnetic field, find the radius of the helical path taken by the proton beam. So radius will be this, and v perpendicular is v sine 60. So you have all the values, so you can find the radius. So that will be 0.012 meter. Now if they ask you find the pitch, then pitch is nothing but v parallel to t. So you need to find the time periods. Time period is 2 pi r by v perpendicular. So you know v perpendicular, you know v parallel. V parallel is v cos 60. So just substitute the value, you will get your answer for the pitch. Let's see the last question. So this is proton, deuteron and the alpha particle have some kinetic energy. Means same kinetic energy they have, all the three particles. Moving in the alpha particle is nothing but nucleus of helium. Means it will have 2 neutrons and 2 protons. So alpha particle will have 2 protons and the 2 neutrons. So the total mass will be 4, means 2 neutrons mass is approximately equal to protons. So that will give you 4 np. So you must remember, and I already told you what is deuteron. So radius ratio we need to find the radius of proton, deuteron and the alpha particle. So and the kinetic energy is same. So kinetic energy given by this expression. So for the proton it will be this, for deuteron it will be this, for alpha particle is this. Let's assume this is equal to k. Now we know this. For the charge on the proton is E and the mass is mp. For deuteron charge is E and the mass of deuteron is 2 mp, and q alpha is 2, means this is the charge, 2 protons there, and mass of alpha particle is 4 mp. So just substitute these values here and find this radius in terms of this k, and substitute the values in the same, means in the terms of mp. Then you will get this ratio 1 ratio root 2 and 1 root to 1. So this will be the ratio between the radius of these three. Let's see the last thing for today, that is work done by the magnetic force. So work done is given by F dot dl, force is this and dl is this. Now see, this v and the v cross v will always be perpendicular to each other, so work done, net work done will always be 0 in the magnetic force. And if work done is 0, then using the means work energy theorem, changing kinetic energy will be 0, means velocity will means speed won't change. Final kinetic energy will equal to initial kinetic energy, means speed remains same, but see, direction will change, means velocity is changing but speed is not changing. So you must remember these results. So in the next lecture we will study the motion in the electric and the magnetic field together. So that's it for today. Thank you everyone.